the right-hand side is 0, but the left-hand side, you consider x, it's a variable of time as well. So when you take derivative of x squared over a squared, you need to consider that power. That'll give you 2 over a squared times x, since x is a function of time, and then times x dot. That's just for the first term here. And we need plus. Do the same thing for y squared over 2. We'll end up with 2 over b squared y times y dot. Okay. So this is what you end up with. Then I want you to look at what we know here. Here inside of this equation, the new equation we get, we know both A and B are given in this problem. And do we know X and Y? We cannot know X, we know Y. If you look at the find, we want to find everything when Y equals 6 millimeters. So we know Y. If we know Y, can we find X? Yes, because we're given this relationship between X and Y. If we plug in Y, we should be able to get a value for X, right? So let's go back. So it seems like we know X, we know Y. X dot is something we don't know. We want to find out Y dot. What is Y dot? Y is a position of that particle P along the track. If you add a dot to a position, what does that tell you? Speed, right? Remember that? If you, in this class, if you see derivative of something with respect to time, that either tells you speed or it could tell you acceleration. Is that right? So Y dot tells you what? Speed on which direction? Y is a position, you take a dot, that gives you speed. And that's the speed on Y direction, since we're talking about Y, position on Y direction. And you take derivative of that position, that would give you a speed on that direction. And do we know that speed in this problem? Look at your givens. What are the givens for this problem? What is this? V equals 30 millimeters per second. And what's the direction of V? It's going up. So, okay, now let's come back. Now I have a question to ask you. What's the relationship between V and Y dot? What's the relationship between those two variables? Are they equal? If you're greater equal, raise your hand. Okay, if Y greater than Y dot, V greater than Y dot, raise your hand. Smaller than Y dot, raise your hand. Okay, answers it, they equal to each other. This kind of like the homework problem, question number 12. If you did all the calculation right, you end up with something S dot in that question. Now you need to realize S dot, it's a position, take a dot, which is a time derivative that tells you speed. Same deal here. V equals Y. y dot. Okay, so now let's proceed. Since we know y dot, we know x, we know y, let's find out the exact value for x first. Since y equals 6, we want to find x, right? You can use that equation, x squared over a squared plus, now y squared becomes 6 squared, y equals 6 over b squared over equals 1. Now you can solve what is x from here. X is going to be positive or negative a squared times 1 minus y. Y becomes 6 squared over b squared. That's an easy calculation to find x. But we have two values for x, either positive or negative. And now you have to decide which number you should use. That depends on where's this particle. If you look at the figure of this problem, is the particle on the left-hand side of the origin or right-hand side of the origin? If we go back to the figure here, particle P only moves on the left-hand side of the coordinate system. So the coordinates for P on X direction should be always negative. That's why here for X, we're gonna take the negative value. If you plug in all the numbers, realize X equals negative 4 millimeters. Okay, so now let's go back to here. Now we know X, we know Y, we know Y dot. X dot is the only unknown. And we can solve for X dot. If you plug in all the numbers, you end up with S dot equals 11.25 millimeters per second. Okay, now what? We solved X dot and we know Y dot. Can we solve for velocity, Vp? Yeah, Vp equals X dot I plus Y dot P or Y dot J. Then just plug in the numbers, you should end up with find out what is the velocity for that particle, which is 11.25 I plus on Y direction, it's just the velocity of that 30 J. And make sure you add unit. The unit here is millimeter per second. And here, this is part velocity. So make sure you have that vector notation. Now we're done with the first part of this example, find velocity using the Cartesian coordinate system. Any questions before we move on to acceleration? It's y is negative. Yeah, okay. Let's look at this. So you're right, our x is negative because the particle P is on the negative side of x, right? We have no problem here. So we know x equals negative 4 and y is positive 6. Then we plug in that two numbers to here, yes. We plug in x equals negative 4 and plug in y equals 6. Then we plug in y dot, it's 30 to this expression, this equation, and then we solve for x dot. X dot end up with a positive number. That makes sense. This is S dot. What does S dot mean? It's speed on x direction. Or you can think it's the x direction velocity component of this particle. So since it's a speed, it can be positive, negative, or zero, right? Now let's talk about acceleration, since that's the second thing we want to find. What is the acceleration at y equals 6 millimeter? So we know under Cartesian coordinate system, acceleration equals x double dot I plus y double dot j. So if we can find x double dot, y double dot, and we're done. We find the answer. So same drill, just you remember what we just did to find x double dot? Do the same thing to that expression here. So now we want to take the derivative with respect to t of this equation, of this. Since we already did the first time derivative for this expression, this equation, we end up with this. If we can take the derivative of this equation again, we should end up something x double dot, y double dot. Let me copy this. Copy. Okay, so same deal, derivative on both sides of equation. Since the other side of equation is 0, derivative of 0 will still give you 0. All right, now I'll give you two minutes to work this on yourself to see if you can find the derivative of this expression here. If you are scared to deal with this something plus something derivative, and you can break it down to two components, to do the derivative for each component like this. Okay, I'm going to write it out my answer so that you can compare yours with mine. So my result is 2 over a squared times x dot square plus x double dot. So what we're doing here, this is a product rule I told you guys to review after class. Plus 2 over b squared y dot square plus y times y double dot equals 0. Okay. So now let's look at what we have inside of this equation. We solved x dot, right, from the last step. X dot equals 11.25, I think. And we know x equals -4. And x double dot is the unknown. Y dot, we know y dot equals v. We know y equals 6. What is y double dot? 0, yes. If you go back to the given condition, this v, 30 millimeters per second, is a constant speed. So if you take the derivative of a constant, you get 0. So y double dot is 0. Y double dot is 0. Okay, now it's pretty clear. The only unknown here is x double dot. And we can solve for x double dot. And if plugging all the numbers, we end up with 87.89 millimeters per second. Anything wrong here? I purposely made a mistake. What is x double dot? Position to double dot. What's the physical meaning of that? Acceleration. Now what's the unit for acceleration? Distance, either meters per second square or millimeters per second square, right? Make sure you have the right unit here. Missing the square here. All right, and what's next? Now we have x double dot, y double dot. The answer is one step away. Acceleration for this particle P, it's just x double dot I plus y double dot J. And plugging x double dot is 87.89 I plus 0J. That's your acceleration for this particle. Unit is millimeter per second squared. And we're done. Okay, I think the hardest part for you is probably the product rule when you do the derivative. Once again, if you have problems with product rule, we outside class do some search on Google, find some tutorial videos on YouTube. If you still have trouble with this product rule, come to my office hour. I can maybe help you out a little bit. That's about this in-class example. So far we did 3 examples in section AB. One for polar, one for path coordinate system, and this one is Cartesian coordinate system. Did you guys see the pattern? Whenever you have a problem, the first question is to ask what coordinate system you use, right? Once you know what coordinate system you use, and you go to that coordinate system, grab the equation either for velocity or acceleration, and you just throw there, that's the equation I want to use. And you look at each equation, what are something I don't know inside of this equation? Either it's rho, either it's theta, either it's r. In this case, we want to know x dot, x, y dot, x double dot, y double dot. Then you use the given information to find those missing parts. And once you have those missing parts, put them back into the equation, you're done. Right, that's kind of the logic for this section. Okay. Any questions on this example? That's all about section AB. Now, we still have a little bit of time left. Let's talk about homeworks. How will you submit your homework? Okay, this is our Moodle page. So first I upload a template example, homework example on the home page. Since someone asked me where to put your name, course title, the number of the homework, and yeah, those are things on the top of your homework on each page, please. And at the bottom, make sure you add a page number. And for homework questions, I know there's a couple on Moodle, there may be 3 or 4 questions just for that same problem. You don't have to do this for each single problem. You can do what I was doing. Sorry, I don't know how to rotate this, but you can tilt your head. And I just write down, this is a number from, this is a problem from question 2 to number 7, and they all share the same diagram, same given conditions, and you can write out what you need to find. And after that, write your solution, give a detailed work of your solution. And one thing I didn't mention, but I expect you to do is for your solution, I want to see symbolic solutions. For example, the example we just did, we have A, B, X dot, something like that. I want to see a symbolic solution at the end. I don't care about the numbers. Since on Moodle, each students have a different set of number for your question. So you all have different numbers, but the symbolic solution should be the same for everyone. So I want to say symbolic solution. I want you to use a box to highlight your symbolic solution. And if you want to, you can plug in all the numbers, give me a final number after that. I want to say symbolic solution. Keep that in mind. Same deal for your exam. I want to see symbolic solution and detailed work. So for example, if you get the correct symbolic solution, you get 95 out of 100 from that problem. Even you did some mistake in calculation, you end up with a wrong number. I probably only take 5 out of 100 off. But you get most of the points. But imagine that if you don't have all the solution, the detailed solution and the symbolic solution, you only show me a wrong number, there's no way for me to give you partial credit. I don't know what you did wrong, so I would take probably half the points, 50 out of 100 off from that problem. So by showing your work and give symbolic solution, it's a way to help yourself to earn partial credits, if that makes sense. That's also make my grading a little bit easier. Okay, so I know most of you probably is writing this homework on a piece of paper, and once you're done, take a picture. I want you to convert that into a PDF file. Upload your homework in PDF file, in one single PDF file. Anybody knows how to convert your picture to a PDF file? Okay. If you don't know how to do so, and there's a very simple way that I usually use is, for example, this is my homework. I took picture. I can upload this to my computer, right? What I want to do is either copy this or screenshot this. Let me do this. So imagine, let's put this on the desktop. Okay, imagine this is a picture you took for your homework. And what I would do is I would create a PowerPoint, all Word documents. Either way, I think Word work fine. I will copy and paste my homework into the Word document. Rotate this. Okay. sure the size is right. I want to make sure I can move this. Then click Save As. Then once you see this, it allows you to change the format. So here I will pick PDF. And if I click Save, and it will save a PDF version of my homework right here. Now I end up with my PDF homework. All right, if you have multiple pages, and same deal, you just create multiple pages in this Word documents, and same thing, save as PDF. The reason I want PDF is everything is electronic. If you submit everything in PDF version, I can easily grade on your PDF homework using my iPad. Otherwise, if you upload a picture, it's very hard for me to grade on a computer or iPad. Okay. Now this is the next thing I want to show you where to submit your paper homework. So if you look at problems homework, and right after it, I created another tab. It's called Format Homeworks. So whenever you see Format Homework, that's when you take a picture of your paper homework and upload to it. So you can just click that, and it will ask you to upload something. Just upload your homework there. I will create a format homework for each problems homework. Remember, we only have paper homework due for problems homework. You don't have to do same paper homework for pre-homework and concept homework. Only problems homework require you to write everything on a piece of paper. Any questions? Okay. And by the way, question number 12, it's, you don't have to worry about Moodle. I will give you points back. There's a bug in Moodle, and think sometimes we will have maybe 2 or 3 homeworks in Moodle that could have this type of problem. No matter what answer you put there, it always tell you it's wrong. So if you have a situation like this, feel free to email me and let me know. Otherwise, I don't know what is happening. If you let me know, I can give the points back to you. I don't want you to lose points due to the technical issue from Moodle. So for question number 12, if it tells you it's wrong on Moodle, don't worry about that. Just put everything on the paper, and I would check that. Okay. All right, next, we're going to spend a few minutes, since we're done with section AB. Going to have a quick test. No, quiz. It's oral test. So don't worry. I'm going to just ask you a few questions and let you guys decide, is that true or false? It's a good way to test if you understand the concept properly. Okay, so if we have a particle, it's a moving particle, is that possible for velocity and acceleration vectors perpendicular to each other? So you have a velocity vector and acceleration vector. Is that possible those two vectors are perpendicular to each other? True, raise your hand. Okay. Yes, the answer is true. You can have these two vectors perpendicular to each other. Can you have these two vectors parallel to each other? Or they're pointing to the same direction or opposite direction? Think about that. So it can be V, A, So particle. Another situation could be they are pointing to the same direction. Is this possible? If you think it's possible, raise your hand. Oh, sorry, I thought this is on the screen. My bad. Oh, right here. Okay. Is that possible for a particle to have velocity vector and acceleration vector pointing to either same or opposite direction? If you think it's true, possible, raise your hand. If you think it's false, raise your hand. Yeah, it's possible. When acceleration and velocity are aligned with each other, that means this particle is accelerating on that direction, it's moving. If they have the opposite direction, what does that mean? Deceleration, right? The speed is slowing down. It's kind of, when you're driving on highway, you step on brake, the car's slowing down. Same deal. Okay. Okay, next question is, so if we have a path, we're using path coordinate system. Our acceleration equation is v dot et hat plus v squared over rho en hat. No, let's change this. I don't want to use. Okay. The thing I wrote, that was from the equation, right? But now I want to write just a and b. A and b represents two variables, two values, can be any values. Now I want to ask you, under the first case, what is happening when a is 0 and b is 0? What is happening when a is 0, b is 0?
The particle has a constant speed.
Has a constant speed. Is that necessary, a constant speed?
Or it could have zero, no speed, but that's also a speed.
Yeah. So if you have both a and b is 0, if you plug them into the equation, you get 0 acceleration, right? For the path coordinate system here, we have v dot, right? So v dot is 0. What is the name for v dot? The rate change of speed. Rate change of speed is 0, means there's no change on speed. It's either this particle's rest or it's moving at a constant speed. Here, b equals 0. What is the equation here for this on this component for path coordinate system? V squared over rho. So what are the cases when v squared over rho is 0? We should have two conditions when it's 0. One, when v is 0, you end up with 0. Or another condition is if your rho is infinitely large, right? That term could end up with 0. Remember, what is here is v squared over rho. If this is 0, that only means either v is 0 or rho is infinite. What happens if rho is infinite? What is going on if your radius is infinitely large? The particle is traveling in a straight line if your rho is infinite. So this is the case when it's traveling in a straight line. This was on your concept homework. Okay. Another condition, that's when a and b are both 0. How about a equals 0, but b is non-zero? What is happening when A is 0, B is non-zero? So the particle is the particle moving? Is that necessary for particle to move, have a speed? If A equals 0, what is there for on ET direction for acceleration? Remember? Right, on there we have V dot, right? From our equation. So which means V dot is 0, means our particle is traveling at a constant speed, probably. And could that speed be 0? The answer is no, because our B is not non-zero at this point. So that means this cannot be 0. So it must be some type of speed, and there has to be a rho that is not infinite to make sure B is non-zero. So under this condition, we have the particle. What is going on here is the particle, it's traveling at a constant speed. But it's taking a turn. Okay, any questions? Okay, now let's look at the third condition here. A is non-zero, but B is 0. So what is going on when A is non-zero, B is 0? Hunter? So particle is accelerating in a straight line. Because A is non-zero, which means the rate change of speed is non-zero. It has some type of acceleration or deceleration. If B equals 0, the second term is 0. That means there's no changing in direction. So the particle is traveling in a straight line. Yes. Straight line, but acceleration or deceleration. Okay. The last case we have is when they're both non-zero. That's the normal case we see, right? Most of the problems we have, they're both non-zero. So they're just, the particle is just traveling, they're changing both direction, and the speed is changing all the time. So what I want to say here is for path coordinate system, A, acceleration has two components, V dot ET plus V squared over rho En. The first component there for the ET component, it's in charge of how fast the speed is changing. And the second component, V squared over rho on ET direction, this component, everything in front of En is controlling the direction how that particle is moving. Does that make sense? Since before this class, everything is just a number. Acceleration is a number. Now we're talking about everything in vector. We're talking about 2D dimensions, so our vector has two components. The ET component is controlling the speed changing. The En component is controlling the change of direction. Okay. Any questions? Another question for you is, that's the 4 different cases. So another test, if the speed, if we have particle is moving at a constant speed, is that possible the acceleration is 0? Okay, another way. If the particle is traveling at a constant speed and the acceleration must be 0, true or false? Raise your hand if you think it's true. Raise your hand if it is false. Okay. Do you mind telling me why you think it's false? What? Say that again, sorry. Either one. Can be changing direction, I heard that. Do you agree? Okay. Yeah. So the answer is false, no. Even it's at constant speed, the acceleration is not necessarily 0 because it could change direction. That could also cause non-zero acceleration. Does that make sense? It's tricky. If that is on your exam, you can easily choose, get tricked. All right. Okay. And that's all about today's lecture. Next time we're gonna start section C. And what I want you to do is go back to, remember the video, I can send out the video again. The video, check out, review yourself how to convert between different coordinate systems. I uploaded video to my YouTube channel and I was resend the link again. I want you to watch that, familiar with how to convert between coordinate systems. All right. And if you have questions on homeworks, you can come up here. I can answer your questions. I think someone emailed me earlier about homework question.